this video is going to be for your mean value theorem. And what it states is that if f of x is continuous and closed on the interval a to b and differentiable in the open interval a to b, then there exists at least one point C in the open interval from A to B where f primed of C, the derivative at that point will be the same as the slope between the endpoints of your interval. So to say that one more time, your derivative is equal to the slope between the endpoints. So what we want to look at is the fact that that the function has to be continuous and closed on the closed interval, but only differentiable in the open interval, and the mean value theorem will hold for a point C in the open interval, meaning it can't be an endpoint. Mean value theorem, it helps to guarantee slopes. So graphically, we're going to look at this graph here, and given point A to point B, which is our interval, I'm going to create a line. What mean value theorem says is that within the interval, I should be able to find at least one place where the slope of the tangent line is the same as the slope of that secant line. And so we have one here, and we have one somewhere around here. MVT guarantees one point, but you could actually have more than 1 point, as I've shown in this picture here. I'm going to do one algebraic problem for you from the book. And so given a function x plus 1 over x on the interval of 0.5 to 4, I believe. 0.5 actually to 2. So we want to see if the mean value theorem holds. First of all, we know continuity is very much dependent on the domain. The domain is that x cannot equal 0, which is not in the interval, so it's definitely continuous. We know it's closed because they gave us 0.5 to 2. And then differentiable, we know that given this function, the only place that it won't be differentiable would be x equal to 0, which is not in the interval. So it is differentiable. So we know that MVT holds. Given that it holds, now we want to find f of b minus f of a all over b minus a. So f of b would be f of 2, which would be 2 plus 1 half, which gives you 5 halves. F of a, which is 1 half, gives you 1 half plus 2, which again is 5 halves. So you have 5 halves minus 5 halves over 2 minus a half equals 0. What that means for us is I am guaranteed that within 0.5 to 2, f primed of some value c will definitely be 0. Let's see. if I did this correctly. Let's see. 2 plus a half, 4 5/2, and then 1/2 plus 2 is 5/2. All right, and so we're going to look at the derivative of the function is 1 plus, so that's x to the negative 1. So we would write that as negative x to the negative 2, which ends up being 1 minus 1 over x squared. We want to say that the derivative, 1 minus 1 over x squared, is the same as 0 at some x value. And so we get negative 1 over x squared equals negative 1, and that we can cancel the negatives. X squared equals 1, and we get that x equals plus or minus 1, but within the interval we can only use positive 1. So at positive 1, what we should be able to prove is that the derivative is 0 there, and that was guaranteed by MBT. So here's the value. It proves us one value within this domain, the open domain I should say, where the slope of the secant line, which was 0, is the same as the slope of the curve, the tangent line slope. This AP problem will show you the other way that the question could also be asked. Looking at a table where f and g are differentiable functions and g is strictly increasing, the table above gives the values of the function and their first derivatives at selected x values. H of x is a composition function, shown here. Explain why, and we're going to actually look at part B. Explain why there must be a value for c between 1 and 3 where the derivative is negative 5. So this is asking us to guarantee a slope of negative 5. When I'm trying to guarantee a slope, the first thing I think about is MVT. So what I'm going to look at is, MVT would say that if you find h of 1, and you find h of 3, and then you find h of 3 minus h of 1 all over 3 minus 1, that slope would be guaranteed. So my guess here is that the slope probably is negative 5. So let's actually do h of 1. H of 1 would be f of g of 1 minus 6. And so g of 1 is the first thing we do, which is 2. So I would be finding f of 2 and then minus 6. Next we do f of 2, which is 9, and 9 minus 6 is 3. Next piece, h of 3. H of 3 would tell me that I'm doing f of g of 3 and then minus 6 after. So first thing I do is g of 3. G of 3 would be 4. So f of 4 and then minus 6. Well, f of 4 is negative 1 minus 6 is equal to negative 7. And so I feel that I have made a mistake. Let's see. F g of 1 is 2. F of 2 is 9 minus 6. G of 3 is 4. And then f of 4 is negative 1, which gives us negative 7. All right. I have not made a mistake. All right. Last piece here. H of 3 is negative 7 minus h of 1, which is 3, all over 3 minus 1. So I get negative 10 over 2, which is negative 5. So my reasoning would be because f of x and g of x are differentiable, then h of x is differentiable. On the values from, looks like 1 until 4. Therefore, by MVT, I am guaranteed that this slope of negative 5 will occur between the open intervals from 1 till 3. And that actually should have been a 3 here. We know that at 1 and at 3 the points exist because it is differentiable, which means also continuous. So the reasoning I would say here is that h of x is continuous, closed on 1 to 3, and differentiable on 1 to 3 because of the composition, because f of x and g of x are differentiable. Therefore, MVT guarantees that h of 3 minus h of 1 over 3 minus 1, which is negative 5, will be h prime of c within the open interval of 1 to 3. So that would be what I would write as my answer, and then my reasoning is all underneath also.